Welcome to Geometry. In this video, we're going to go over the Chapter 12 review. The first four are multiple choice. So let's see, in the first one here, we got two quadrilaterals. I'm just going to label my rectangles down here, I, J, K, L. And the other one in the same order, starting in the same place, M, N, O, P. And IJ is 150. JK is 12. MN is 225, and NO, what is the measure of NO? So I'm just going to call that X. So we can set up a proportion here. I'll set it up one way here in this triangle on the left. I'm going to do my numerator from here and denominator here, so we could write 150 over 225 is equal to, same order, numerator 12, denominator X. And we could cross multiply there. Or in the other rectangle, I'm going to set it up staying in the same rectangle. I could do maybe 150 over 12 is equal to 225 over X. Both of these setups are good. When we cross multiply here, we'll multiply the 150 and the X, same on this side. And the other diagonal is 12 times 225. So at some point when we do that cross multiplication, we're going to get 150x is equal to 2,700. We divide by 150, and our answer is C, 18 centimeters. Question 2. Which similarity theorem can be used to triangles shown are similar? So let's see what we got here. Angle, angle. Well, that would say that the triangles are similar, but we have no angles in any of the triangles. Side, side. That's just two sides. I've never heard of that theorem, so that's probably not it. And then on the other two, C and D, these at least look familiar. We have side, angle, side. That was congruence and similarity theorem. And then here's the one we're probably looking for, side, side, side. We got all three sides in each triangle. That would be the one. Okay, and question 3. In the figure, triangle JKL has the properties shown. Which proportion would be correct for triangle JKL? Well, we got our parallel lines marked, so what we should have is this piece will be proportional to this piece. So I could write that as KM over MJ is equal to, over here I'll keep the same order, LN over JN. Now, what I wrote here, remember, we could write the letters in either order, and we could even flip our fractions upside down. And this one here on the left, if I flip it over and reverse the letters, so I could have wrote MJ as JM, and KM as MK. And I'm going to do the same over here. Well, I'm just going to flip this one over. I'm going to put the JN up top and the LN in the bottom. And now it looks like it matches letter C. We got JM over MK. Here's JM over MK. And the other one is JN upstairs, and NL downstairs. I could just write that one backwards. So there's our answer, C. Question 4. In the figure, triangle ABC has the dimension shown. DE is parallel to AC. Let's mark that. Here's DE parallel to AC. So now we can apply one of our theorems. It says, what is the length of AD? I'm just going to call it X. And we can set up a proportion. 12 over X equals 15 over 45 would work. Or you could flip them upside down. It doesn't matter. So if we multiply here, we're going to get 15X is equal to 12 times 45. That's 540. 540. And if we divide by 15, X is 36. Our answer is B. Number 5. In the figure, the quadrilaterals have the dimensions shown. For what value of X would make the quadrilaterals similar? So again, we've got corresponding sides between these figures. Let's set up a proportion. One way to do it, I'm going to do this is my numerator and this is my denominator. So in the first one, it would be 225 over 450. And that would equal the fraction on the other one, same order, corresponding sides. That would be 200 over top of the quantity. Now, I'm going to put this in parentheses. Ooh, little glitch. There we go. 3x plus 70. Now I did to put that 3x plus 70 in parenthesis because when we cross multiply, that 225 is going to need to be distributed. 225 times the quantity 3x plus 70. Set that equal to 200 times 450. Oop, my pad is glitching here a little bit. I'm trying to write 450. And when you distribute the 225 and multiply the other side together, at some point you should get to 675x is equal to 74,250. And when we divide through, we're going to get x equals 110. So there's our answer to part A. X value of 110 would make those quadrilaterals similar. And then it says, what is the scale factor of the pre-image to the final image? So we want to set this up. We could do 200 over 225. I'm just going to write the answer to part B up here. 200 over 225. Here's our 200. Here's our 225. That's the side that we know both at the start of the problem. And let's see, this would be our pre-image, and then this would be our image. So we're going to set that up as a fraction, image in the numerator, pre-image in the denominator. And that would reduce down to 8/9, or if you punch it in your calculator, you're going to get a decimal 0.8 repeating. Oops. Question 6. A tree and a fence post cast shadows that end at the same point on the ground. So again, here is our tree. And then here is our post, and the shadows meet at a point out here. If I draw in black ink, this would be the shadow of the tree and the post coming together. Part A, which statement about the triangles formed by the objects and their shadows is correct? So read through those. The answer is B. The triangles are similar because two pairs of corresponding angles are congruent. We've got the right angles here in the corner by the tree and the post, and then this angle at the very tip here would be shared between both of the triangles, the big one and the small one. Okay, now here in part B, it says find the length of the shadow. I blew the picture up a little bit, so I'm going to draw the shadow in there again with that black ink. Okay, and I'm going to show you kind of two ways we can set this up. Let's call the distance from the tree to the post X, and we've got the 25-foot tree and the 10-foot post. So we could set up a proportion. I'm going to come up here in the left, 25 over 10. So I did this is my numerator, and then from the post triangle is my denominator. And then I could set that equal to, this entire side here would be the quantity x plus 22 over top of, from the smaller triangle, just the 22. So if we solve this, we're going to get x. So we're going to have 10. That'll need distributed over the x plus 22 is equal to 22 times 25. When it's all said and done, you should get x is 33. Now be careful, they did ask for the entire length of the shadow. So again, back down in the picture, if I scribbled over it here in the dark ink, we found x. X here is 33 feet, but then there's 22 more foot of shadow. So the 33 plus the 22 would equal a 55-foot shadow. Now that's one way to do it. There is kind of an easier way. I'm going to highlight the bigger triangle in red. So here's a big triangle. And let's call this entire side X. And then we've got the smaller blue triangle made up by the post. So I could set up a proportion here. I'm going to do 25 over 10 just like we did above. But now that's going to equal 22 x over 22. So this, if the proportion's a little different if you look at what we have up here, but this, our final answer, will be the entire shadow. So we're going to have 10x equals those multiplied together. When you divide through by 10, those would multiply to 550. When you divide through by 10, you're going to get the final answer, x is 55, because we set it up to solve for this entire side. All right, in number 7 here, this might be, some students think this would be the more confusing on the review. We've got 3 triangles here, and what I like to do is I'm going to pull them apart down below. So the big overall triangle is this one. We've got angle B, down the short side to the right angle, angle A, and then down the long side to angle C. We're going to do that same setup here. In triangle 1, the right angle is at point D, and down the short side would mean A is up here at the top. And then we would go out here to C. Now the little triangle 2 is up here. D is the right angle. The short side runs up to point B. And then A would be this point down here on the end. So now that I've got the triangles pulled apart, they're all oriented with the right angle down in the lower left. Let's read these statements. So the first one says triangle ABD. That's got to be this one on the end. So they're starting here at the tip. They're going up the hypotenuse to B and then down to the right angle. Whoa. So is that similar to CAD? So here we're starting at this tip. We're going up the hypotenuse to A, and then we're going down to the right angle D. That is the same pattern, same order. So that's going to be true. The next one, DAB. So now they're starting here at D and going down the long side, and then they're going up the hypotenuse, DAB. And is that similar to DAC? So now they're starting at the right angle, going up the short side. So no, already we can see that's going to be false. Third one, triangle ABC. So now they're starting at the right angle, going up the short side, and then down the hypotenuse. Is that similar to ADC? No, here they're starting at the top and then going down to the right angle, so we can already see that's going to be false. Final one, triangle ABC. Again, right angle, up the short side, down the hypotenuse. Does that match up to DBA? So here's D, right angle, up the short side, down the hypotenuse. That's going to be true. All right, and I believe this is the last one. Yes. A couple ways we can do this. We could attack it all with the proportions. If I wanted to find this side, if I want to call this x, I could start out with 30 is equal to this little chunk 10. Ooh, there goes my pad again. To this little chunk 10 times the entire side length here. That would be x plus 10. And we could distribute the 10 and solve for it that way. That would be one way to go after it, using our newer theorems. Or we could do Pythagorean theorem here to find UW. A squared plus B squared equals C squared. So I'm going to write 10 squared plus B squared equals 30 squared. And that would be 100 plus B squared. Why is my pad malfunctioning? 100 plus B squared equals 900. And then we would subtract 100 from each side, and we would get A squared equals 800. That's supposed to be an 8. And then we take the square root of that, and we get about 28.3. 28, let's make it 0.28, another decimal of accuracy. Okay, so we found that UW, and I'll keep it right here, 28.28. And I'm going to color it here in blue. Now we do have one of our geometric mean, new sort of proportions here. To solve for, put 28.28 there. To solve for this x, again, we could do 30 is equal to the root of 10 times the quantity x plus 10. Or now that we've got that UW, we could set up 10 over 28.28 is equal to 28.28 over x. And then we could cross multiply here and get 10x is equal to 28.28 times itself. Ooh, and there goes my pen glitching again. And when you solve this, you're going to get x equals 79.97. So we can just round that off to 80. And what we found there was TW, so that'll be this last one over here. That's our 80. And the last thing we got to find is TU. Oops. Why is... There it is. So we want to find TU. I'm going to highlight that side in red. So here's TU. Now that we've found TW, I'm going to scribble that out, put an 80 there. So we could do TU is equal to the root of, this red side here. It's closest to this chunk, 80. And we would multiply that 80 by this entire side length. That would be 90. So we could do the square root of 80 times 90. And 80 times 90 is 7,200. The root of 7,200 is about 84.84. Now, another way to find TU, we could have just gone back and done the Pythagorean theorem again. We know that TW was 80, and that makes this entire side 90. So we could have done 30 squared plus TU squared equals 90 squared. And that would also get us to the same answer. And that is the end of the review. Have fun on the test.